Hey everyone, welcome back to the channel. Today, we're diving deep into one of the most powerful search technologies that's revolutionizing how we find information, hybrid search. If you've ever wondered why some search engines seem to read your mind while others completely miss the mark, you're about to find out. We'll explore how combining traditional keyword search with modern vector search creates search experiences that are both precise and intelligent. Before we jump in, if you find this content helpful, smash that subscribe button and hit the bell icon. It really helps the channel grow. Let's start with the basics. Hybrid search is exactly what it sounds like. It's a search approach that combines two different search methods to give you the best of both worlds. On one side, we have traditional keyword search, also called lexical or sparse search. This is what you're familiar with from Google's early days. It looks for exact word matches and uses techniques like TF-IDF. On the other side, we have vector search, also called semantic or dense search. This uses AI embeddings to understand the meaning behind your query, not just the specific words. Hybrid search intelligently combines results from both methods, giving you matches that are both precisely relevant to your keywords and semantically similar to what you're looking for. For example, if you search for apple, fruit, nutrition, keyword search finds documents with those exact words, while vector search might also find content about Red Delicious health benefits or Granny Smith vitamins, even without using your exact terms. You might be thinking, why do we need this complexity? Well, both search methods have their weaknesses when used alone. Keyword search struggles with synonyms, context, and intent. Search for car repair and you might miss great content about automobile maintenance or vehicle servicing. Vector search, while great at understanding meaning, can sometimes be too fuzzy. If you're looking for a specific product model, like iPhone 15 Pro Max, vector search might return results about premium smartphones, technically related but not what you wanted. Studies show that hybrid search can improve search relevance by 25 to 40% compared to using either method alone. That's a massive improvement in user satisfaction. This is why companies like Amazon, Netflix, Spotify, and Elasticsearch are all investing heavily in hybrid search. It's becoming the new standard for search experiences. Now let's look under the hood. The hybrid search architecture has several key components working together. First, during indexing, your documents go through two parallel processes. One creates traditional inverted indexes for keyword matching, and the other generates vector embeddings using models like BERT, sentence transformers, or OpenAI's embeddings. When a user submits a query, the same dual processing happens. The query gets tokenized for keyword search and embedded into vector space for semantic search. Both searches execute in parallel. Keyword search queries the inverted index, while vector search performs similarity matching in the embedding space, typically using algorithms like HNSW or IVF. Finally, the magic happens in the fusion layer. The results from both searches are combined using algorithms like Reciprocal Rank Fusion or learned ranking models. This entire process typically happens in milliseconds, giving users fast, accurate results. Now, this is where things get really interesting. Let's break down the fundamental difference between dense and sparse vectors. Sparse vectors, used in keyword search, are mostly zeros. Think of a vector where each dimension represents a word in your vocabulary. For the phrase red apple, you'd have ones in the positions for red and apple, and zeros everywhere else. These vectors are sparse because most values are zero. They're exact but don't capture semantic relationships. Dense vectors from neural embeddings are completely different. Every dimension has a meaningful value, typically between -1 and +1. These 768 or 1536 dimensional vectors encode semantic meaning. Here's the cool part. Similar concepts cluster together in this high-dimensional space. Apple and orange would have similar vectors even though they share no common letters. This is why vector search can find semantically similar content that keyword search would completely miss. Result fusion is where the art meets the science in hybrid search. There are several approaches, but let's focus on the most popular ones. Reciprocal Rank Fusion, or RRF, is elegantly simple. For each result, you take 1 divided by its rank position, do this for both result sets, then add them together. Alternatively, you can use weighted fusion, where you control how much each search method contributes to the final results. The alpha parameter lets you tune this balance. Alpha equals 0.7 means 70% weight to keyword search, 30% to vector search. This gives you fine-grained control over search behavior. Advanced implementations use machine learning models trained on user interaction data to dynamically determine the optimal fusion weights for each query.
Let's walk through a concrete example to see hybrid search in action. Imagine a user searches for sustainable energy solutions for homes. Let's see what happens. Keyword search finds documents containing these exact terms. Top 10 sustainable energy solutions for modern homes, home energy solutions, a sustainable approach, sustainable living, energy-efficient home solutions. Vector search, understanding the semantic intent, also finds solar panel installation guide for residential properties, wind power for homeowners, a complete guide, eco-friendly home, renewable energy options. Notice how vector search found relevant content about solar and wind power without containing the exact search terms. The hybrid system combines these results, ranking documents that appear in both result sets higher, while also including the unique finds from each method. The result? Users get comprehensive coverage with both exact matches and semantically related content they might never have found otherwise. Now let's look at how you can actually implement hybrid search. Several platforms make this easier than ever. Elasticsearch 8.0 Plus has native hybrid search support. Here's a simple query. Weaviate offers hybrid search with automatic result fusion. Pinecone recently added Sparse dense hybrid search. The benefits of hybrid search are compelling, and they're backed by real-world results. First, improved accuracy. Companies report 25 to 40% improvements in search relevance scores when switching to hybrid search. Better coverage means you catch more relevant results. Keyword search might miss 30% of relevant documents due to vocabulary mismatch, while vector search might miss highly specific technical terms. User satisfaction increases significantly. Studies show 35% higher click-through rates and 28% longer session durations with hybrid search. Multilingual capabilities improve dramatically. Vector embeddings can bridge language gaps. A query in English can find relevant content in Spanish or French. Domain adaptation becomes easier. You can fine-tune the vector component for specific domains while keeping the keyword component general. Finally, robustness against query variations. Whether users type COVID-19, coronavirus, or pandemic, hybrid search handles all variations gracefully. But hybrid search isn't magic. It has limitations and requires careful implementation. The main limitation is complexity. You're now maintaining 2 search systems instead of 1. This means more infrastructure, more tuning, and more potential failure points. Computational costs are higher. Vector embeddings requires significant processing power, and storing dense vectors needs more memory than traditional indexes. Parameter tuning becomes critical. The fusion weights, vector dimensions, and similarity thresholds all need careful optimization for your specific use case. Here are the key best practices. First, start with your data. Analyze your corpus and query patterns before choosing embedding models. A/B test fusion weights. Don't assume 50-50 is optimal. Test different alpha values. Monitor both systems. Set up separate monitoring for keyword and vector search components. Cache embeddings. Pre-compute document embeddings to reduce query time latency. Use quality metrics. Track both precision and recall, not just overall relevance.
The future of hybrid search is incredibly exciting. Let me share what's coming next. Large language model integration is the biggest trend. Instead of just combining keyword and vector search, we're seeing LLMs re-rank results and even generate synthetic queries to improve coverage. Learned fusion models are getting smarter. These systems learn from user behavior to automatically adjust fusion weights in real time based on query type, user context, and historical performance. Multimodal hybrid search is emerging. Imagine searching with text, images, and audio simultaneously, all fused into a single ranking. Real-time personalization is advancing. Hybrid search systems are learning individual user preferences and adapting fusion weights accordingly. Federated hybrid search across multiple data sources is becoming standard. Search across databases, documents, images, and APIs with unified ranking. Industry adoption is accelerating. By 2025, analysts predict 70% of enterprise search implementations will use some form of hybrid search. And that's a wrap on hybrid search. We've covered how it works, why it's powerful, and where it's heading. The key takeaways. Hybrid search combines the precision of keyword matching with the intelligence of semantic understanding. It's more complex but delivers significantly better results for users. Whether you're building a new search system or improving an existing one, hybrid search should definitely be on your roadmap. If you enjoyed this deep dive, check out my videos on vector embeddings and Elasticsearch optimization. Don't forget to subscribe for more content on search technologies, AI, and data engineering. Ring that notification bell so you never miss an upload. Thanks for watching, and I'll see you in the next one.